guys, the Wood Craftsman here, and this is going to be a short video. It's going to be part of probably a 2 or 3 part series. I've got to build a couple of custom flat panel doors for a client. It's actually just 2 doors, but I thought I'd just kind of go show you the process of it. But this first part of this video is actually going to be a tooling change. A while back I had posted a video about my door building process, how I build a raised panel door and drawer front, and that was for a new door style launch for 2015 that we had offered here. And get some comments saying, you know, I should build my own or should buy my doors versus build, blah blah blah. And you know, there's been some other comments similar to that and about how it's not efficient to build your own doors. And a lot of things I got to say is that I can make a whole video on as far as why I don't buy my doors and why I build them. But really it's kind of preference as far as how efficient you are at it, as far as how much of it that you do. But one of the biggest, several of the biggest key things as far as why I build my own doors versus buy my own doors, cost effective. If I was doing a lot of kitchens, a lot of production, I would probably want to buy my doors, or I'd have a separate shop or an area dedicated to strictly just building doors. I've seen a lot of comments on WoodWeb talking about buying versus you know, making your own for the cabinet shop. And that's not what this is about. This is, you know, the small shop where we build all of our own doors here, just for the simple reason that we have 100% control of quality. When we start a job and we order materials for that job, all the face frames, doors, drawer fronts, toe kickboard, anything made out of solid stock gets cut out of that lot of material. And there basically we can process all our face frame stock and also yield all their door stock. And then when it gets time to get sanded, to go through a wide belt, everything goes through the wide belt with the same sanding sequence. So in a past life I've dealt with this issue as far as buying doors from a supplier and then finishing face frames in-house and finishing doors bought from a supplier. They didn't match. Even with a little bit of orbital sanding that we did in-house, they still didn't match all that well. And that's just one thing that I'm avoiding of. The other thing too is if I screw up a door, if I drop it, if I misdrill it, or if I have an accident with the hinge boring machine, I don't have to pay somebody else to build that door for me, especially if I need it in a rush, because just like any other business, if you want something faster, you're going to pay for it. And I'd be the same way. If somebody wanted something from me and they wanted a quick turnaround time, I'm going to charge more for it because it's a convenience fee. Doesn't necessarily make it right, but it's part of doing business, and I don't always agree with the way it's part of doing business. But like I said, there's so many things that I can control here that I can't control with buying doors from someone else. And if you buy from a large shop, we got Caldor in California. There is, I'm thinking of some of the ones I know of. There is Wallscraft, I think they're in Wisconsin. There's Fullwood up in Minnesota. And there's a place, I think in Texas, or maybe it's not Texas, it might be Michigan or something that I know of. And the thing is all of these places have other factors to that need to be added when you purchase doors, when you build everything else in-house. So, and I'm old school. I went to school for cabinet making and wood finishing, and we were taught about, you know, building a door process, how to be efficient about it, things like that. So I just kind of want to take that brief moment to kind of insert that in there, because I mean I get some comments of people telling me that I should not build my own doors, I should buy them. And you know, maybe cost effective wise, yes, you pay more up front for the doors ahead of time and you free up more time for yourself to maybe squeeze the job faster. But at the same time, like I said, I have 100% control of how these doors are built. If I don't like something on these doors, it's myself to blame. I can't go back to this person and say, hey, you built me these doors, I don't agree with it. Being that we stain and finish everything ourselves here in the shop, I just like to have a control over everything that goes on in the shop. Like I said, some people might argue and say, hey, it's not cost effective. The way I build doors, it's not cost effective for me to just build doors for someone else. I'd have to make an investment on more equipment, so I wouldn't have retooling time and just a couple other little things. But like I said, for me, this works out very, very well. Some people might argue and say, hey, nope, you should buy them. You know, the capability. That's not their call. My call is I want to build my own doors because I have control over what I'm putting out. And the nice thing about the tooling that I use, that a lot of professional shops use as well, is the insert tooling. Insert tooling is really kind of the way to go. If you're the really small shop and maybe like a real serious hobbyist or just a DIYer, insert tooling is not really cost effective for you unless you get a really good deal on it. You know, some used stuff off of eBay or something. But if you know, if you're serious about building doors, insert tooling has come a long ways, and the cost is really improved. Used to be when insert tooling came out, it was kind of expensive, but the trade-off is that the tooling lasted a lot longer. You know, most of my tooling is made by a company called Dimensions and Tooling. They're located in Indiana, and the cost of a new head with inserts of a custom head, because they don't really stock anything, it's the same price as a stock item for some of these other ones. And if I want to make a change, they make that change. They send me the drawings via email. I can make the changes. They reproof it, send me the new changes, and I okay it from there, or however long it takes. And there's no engineering fees for that. So the cost of the heads are extremely reasonable, and the cost of the inserts are extremely reasonable. And they're pretty much willing to make any type of a shaper cutter head or a molder head, and some other custom tooling. So that's how I got into this, was the Dimensions and Tooling. They're just it's a really nice company to work with, and extremely reasonable cost. So that's what I've been running here for a while. So but anyways, I'm going to show you here the retooling process. It's actually pretty quick. Alright, so this is going to be basically retooling. First I'm going to unplug the shaper. Safety first. I know you guys don't always see me do this, so I just want to point it out, unplug it. You want to make sure that you get this nut tight, but you don't have to be Armstrong about it. You want to get it good, but you don't want to basically wrench on it with 350 foot-pounds. You definitely want it tight, because you don't want to spin the spindle inside the cutter. Did that many years ago once in a hurry, and it sucked because I had to work pretty hard to get the cutter off the spindle, especially if you got two dissimilar metals. The head I was running was aluminum, which you can imagine what happened, but it worked. I got it apart and salvaged everything. But you know, that's it. I'll have to do a minor height adjustment with this particular profile, but there will be no fence adjustment. So and as you'll see when I do the coping and sticking process, there's no height adjustment either once this is set. And if you saw me put the spaces on there, that's why the spaces are there, because now I have these two cutters perfectly spaced to each other with the use of the coping jig. Here's another little tip. On most of these shapers and some of the Taiwanese knockoffs, they don't have it, but on on a lot of Power Max and the Deltas, they have a knob in the middle here which is designed to lock the spindle, and it actually works really well. But the one thing you want to keep in mind is that when you're adjusting these, there's a little bit of slack in the whole assembly. Even if you got a brand new one, I don't care what brand it is, there's going to be some slack. And I always, if I have to lower the spindle for whatever reason to get to my target, I will actually lower it past its position and raise it up. And the reason I raise it back up again is because I'm taking all the slack out of the mechanism that raises and lowers the spindle cartridge. So just kind of keep that in mind, because if you have this tight and you say you've lowered it, even though you've tightened this assembly here, but the spindle itself can still move ever so slightly. So that's why it's important to, if you're lowering for your depth, bring it past your depth and then raise it and just basically what we call sneak up on it to get your appropriate height, but make sure you're doing it in the up position, because that'll take the slack out of the raising and lowering mechanism. A little trick I learned about 20 years ago. Alright. So okay, so that should be it basically. Like I said, that spacer set you saw me put on earlier basically makes sure that the top of this cutter is basically lining up with the groove on the bottom color. So basically when I cut the tenons first and I stop coping and go to the sticking, that this cutter is in the right position. This now is ready for that door setup, and the next part here, I'm going to actually go through the machining part of the stiles and rails. So anyways, yeah, just wanted to show you that. So the next part of this video, like I said, I'll actually be showing the machining of the parts. And the doors I'm making are actually 8.5 wide by 29.5 long, and they got 2 3/4 inch wide stiles. So that little rail is going to be 4 inches finished. And as you can see here, that's not going to work with the power feed, but I'm going to show you how I do that. Okay, I'm going to just run a quick test piece, make sure everything is good, check a couple little things, and then basically this is going to be ready for building those 2 doors. Okay, so you see it here. There is no heavy lip on either side. The tenon is, or the groove is centered in the tenon, and now we're going to see if they're flush, and they are perfect. I mean perfectly flush. Now this can vary a little bit depending on how clean the sled is and how clean the surface is, but this is, you could sand this by hand. I mean, this is probably more flush than the sides of the cabinets after flush trimming them. So you know, the one key is making sure that you don't have a lip on either side of this. I mean, as you can see here, it's just fuzz, and this is done with those shims and that spacer. So I don't remember how many thousands I have this spaced apart, but I mean, if I had a little bit of a lip here, depending on which side it was, I either have to add a spacer or remove a spacer or rebalance the spacers and change the configuration. But that's, I mean, I don't know if you can see that or not. That's flush. So, and you know, here then you can see that it's pretty much perfectly centered. So, and that's the, let me turn the power feed off here. That's the one nice thing about the tooling that I use, the dimensions in tooling. Every shaper cutter that I order from them has the exact same minor diameter. Some of you may be asking, what's a minor diameter? Well, in a shaper cutter and router bit, you have a major and minor diameter. Major diameter is the overall diameter of the cutter. Minor diameter is the smallest part of the cutter that actually does the cutting. In this case here, all of my tooling from Dimensions in Tooling is actually made at 3.75 inches in minor diameter. So when I make a tooling change here, there's no fence adjustment because every cutter has the exact same small or minor diameter. So everything cuts the same. Doesn't matter the profile. On this particular one, I had to change the height a little bit for the overall setup, but as you saw, there was no change between coping and sticking. So, all right. So the next part of this video, I'm going to actually do the do the coping and sticking process of the door parts. Now, just to clarify, in case I get a keyboard hero out there telling me that this isn't very efficient, I don't cope a rail and then stick it right away. I cope everything first and then I stick everything. So I'm not constantly changing this setup. I do all the tenons first, and once I have all the tenons run, then I go and I run the groove. Now, in the two doors that you're going to see me build, you will see me set the tenon twice, but there's a reason for that, and there's a very good reason for that. For us to buy doors, I think we can do it reasonably, but kind of going back to the previous conversation about building doors for other people, when I did that for a couple friends of mine, I saw an immediate difference when I went to go finish everything, because he actually had contracted me to finish the cabinets as well, so it's kind of nice. I built the doors and drawer fronts, and then he built the cabinets, and then he brought the cabinets here when I had the doors and drawer fronts done, and then I finished everything. And the one thing I saw on a couple of jobs is he wanted red oak, and he used red oak, but the color of his red oak was just horrendous. It was kind of a real pale looking tan. It didn't have that nice reddish brown hue to it. Now that goes back to saying that there's no two trees alike. But what I saw was that his oak was consistently a different color than what I had, and that goes back to my very first part of this conversation. Was the reason that we build our own doors here is because we have 100% control of the quality of the door, because we're cutting all the same lot of material that the rest of the cabinetry is coming from. So, alright, I have talking way too long here, but look forward to the next video where I actually do the building process of these two, I guess you kind of call it a shaker style door, and we'll go from there. Alright guys, thanks for watching. Questions and positive comments are welcome. Thank you.